what we're going to look at today is application of sine and cosine functions. It's actually modeling periodic behavior. I will go through some periodic behavior that we will be looking at, and a few things that you really would need to know. Next year you'll be working on quite a bit of this as well. Alright? So make sure that you get your basic right. So you should be able to apply the knowledge of trigonometric functions as period function to model and solve practical problems. Now, when you're modeling using trigonometric functions, remember radians only, nothing else. You cannot use degrees. You must use radian. If you do not use radian, you will not get the right answer. Alright? So periodic behavior, a phenomenon that moves with periodic behavior, is one that repeats over the time with an aspect of predictability. Hence we can use trigonometric function as period function to model those phenomena. One of the example, sunrise and sunset. Alright, although we've got various different time of sunrise or various different time of sunset, there is actually a pattern when sun is up, when sun is down. Right? So you could actually model it in terms of up and down, although the wave might go smaller and larger and those sort of things. It's not consistent. Something like a Ferris wheel. If you look at the height at the top to the bottom, that will be very consistent. It will be going up and down. Correct? Yeah? So Ferris wheel will be consistent. Tidal wave. Wave will come in and out. That's again not as consistent but good enough to model. Even sunrise and sunset, you can use trigonometric function to model it. Other thing, blood pressure. Blood pressure is actually cyclic. So you just go up and down, up and down. Now realistically, we will only use sine and cosine functions to model this behavior. As it is rare to come across a periodic phenomenon that is asymptotic, which is tan. So we very seldom, not that I've seen any tan. Alright? So radian measure is used when modeling periodic behaviors. That's important, radian measure. Now, there are two possible equations, sine and cos. So you got A equals B, x minus c plus d, or y equals A cos B, x minus c plus d. Of course you know is that A is the amplitude, B is the period, C is the phase shift, D is equilibrium shift. Alright? Amplitude, up or down. Multiply, if x equals to sine x, A times sine x, it will go up to A and minus A. Correct?
Yep.
So you're thinking about what the amplitude is. Period is generally 2 pi, but you should be able to work out what the period is looking at the graph. Phase shift. Remember, I said sine, if you shift it by 90 degrees, it will become cos. Or cos shifted by 90 degrees, it will become sine. So that's a phase shift. And then equilibrium shift, where the equilibrium is going up and down. So for example, if you use a ground, if you are doing something, use the ground as the as point 0. But if you think about a Ferris wheel, moving up, the equilibrium is moved from 0 to certain part, the center of the Ferris wheel. Alright, I'll use a Ferris wheel as an example a little bit later. So you must know A, B, C, and D. Back to your B cat. Alright, you start with your period, and then the phase shift, and then A and D. Alright, now, the few things that you can think about. In nature, rising and setting of a sun over 24-hour period. Tide levels over 24-hour period. Let's see if I can get that out. If I can't get that out, it doesn't really matter. That's enough for you to play around. Temperature changes over year. That's quite interesting. I have looked at rainfall data rather than temperature. Of course, rainfall data, again, is I don't model it using trig function. I model it something else. Alright? But of course, you can use that. Lunar and solar tides, temperature change for sure, the population change over a year. We'll look at the predator and prey models a little bit later. So man-made phenomena, oscillation or vibration of a spring. I'll show you a graph a little bit later. Vibration in terms of sound and light wave. Waves are all oscillating. Sine wave, radio signal, electric generators and alternating currents, wheels, bike wheels, Ferris wheel. And then things like blood pressure, biological clock, and circadian rhythms, that sort of stuff. Alright? Alright, now let's go back to my PowerPoint. It was going to that it was going to show this, but so I'm just going to ignore it now. Don't worry about that. Let's go straight to this. So if you look at this, now if I've got a spring, if I pull it down, it will go moving up and down, correct? Now I want you to see the changes when it moves up and down. This is the velocity, this is the displacement, this is the acceleration. Alright? Look at it. If you keep going, it's non-stop. It can go on and on and on and on and on. So you can model it using sine wave. Now by the way, this you'll be learning it in calculus again. You're going to link the displacement to velocity to acceleration. Let's have a look at it again. I did not design this. I got this from a website. Pretty much you can see displacement down. That's the equilibrium point, down and then up again, and it will keep going if the springs goes up and down. Alright? Alright. So let's have a look at example 1. It's a predator and prey model. The predator population P is modeled by using the function P equals to cos 2t plus 8,000 when t is measured in years. Alright? If you look at equation like this, very obvious, what is that? What is plus 8,000?
Equilibrium shift.
Hey? What is 8,000? The starting point, and is the y-intercept, correct? Yeah? Now, you've got to be very careful about units. Units in this case is actually here. Alright? So, unit is here. So what it looks like is something like this, the predator and prey model. So this is the time. So, and it will go up and down and up and down. Alright? So if you think about the predator on the prey, if there are lots of food for them, they will start eating or hunting. And then as soon as whatever they have hunted has gone down, the predator will go down. The population of predator will go down slowly and then up. So it is a sine effect, sine wave effect. Alright, so you need to determine the maximum and minimum population. So something like this, that's just a sketch. I don't know whether it's right or wrong, but that's just a sketch. You could use ClassPad to plot it if you want to. Now, we know we can work out the maximum and minimum value. How? Looking at cos 2t. What is the maximum of cos 2t? What is the minimum of cos 2t? Yeah? So max cos 2t, max of value of cos 2t is actually equals to 1. Correct? And minimum value of cos 2t equals to minus 1. Therefore, P max equals to 900 plus 8,000, which is 8900, and P mean equals to 8,000 minus 900, which is 7100. Which means you would be able to get this is a maximum, which is 8900, and that is minimum 7100. All right. So determine the length of times in years. between successive population maximum or minimum. So you're going to look at what is a period. Alright, maximum to maximum or minimum to minimum, that's a period. Alright, so therefore you know period equals 2 pi over b. Alright, what is b in this case? What is b in this case? B is 2. Alright, cos 2t, b is 2. So it's 2 pi over 2. So therefore that's pi. Alright, so now period is actually pi years or 3.14 years. So every 3.14 years is go through a cycle. So the length of time between successive cycle is 3.14 years. Alright, so it's how you work out the period. Any question here before I move on to question 2? Alright? Yeah? So you think about what the maximum value is and minimum value is of cos. Cos, you do have a maximum, you've got a minimum. Plus 1 and minus 1. Alright? So ignore the amplitude, think about that. Yes?
Why do you have to divide by b to find?
It's a period. Remember when we have when we have the period shift, when we are looking at the transformation, we always define period equals to 2 pi over b. Yeah? Alright? Alright, let's go to the next question. Example 2. Each time your heart beats, your blood pressure increases and then decreases as the heart rests between beats. The blood pressure of a particular person is monitored and modeled by the function of Pt equals 115 plus 225 sine, sorry, it should be the same line, 160 pi t. When Pt is the pressure in millimeter mercury and at time t minutes after initial observation. So you need to think about how you could use P of t, P as a function of t equals 115 plus 25 sine 160 pi t. Now, you could determine the amplitude of the blood pressure as well as the period based on the information given, can't you? So what is the amplitude? What's the amplitude? Amplitude is 25 because you know that we are modeling based on this. A is amplitude, alright? B is a period, C is a phase shift, D is the equilibrium. Right? So now amplitude of blood pressure is 25, again millimeter of mercury. Alright? Do you know how this came about? Alright. You probably haven't studied in physics. So that came about when somebody wanted to measure pressure. So what they did is fill in a test tube, which is I think up to probably 100 millimeter or something like that, and then invert it over a bath of mercury and let it settle, and that is considered as the pressure. That's how they measure pressure. Alright, I can't remember the exact detail, but I know they use mercury for that. That's why it's millimeter Hg. Okay? Alright, so period of the blood pressure. What is period? Period is 2 pi over b. So 2 pi over, period is 2 pi over, yep, that's 160 pi. Therefore is 1 over 80 minutes. Yeah, you can see your heartbeat. It's actually quite right, 1 over 80. Your heartbeat is, let's say, average of 75 to 78, depends on how fit you are. That's quite all right, 1 over 80. Nothing wrong with that. Okay, so the period between your heartbeat is 1 over 80. Okay, so calculate the initial blood pressure of this patient. So initial blood pressure would be, that would be 0, correct?
Yeah.
Sine equals to 0. So therefore the initial is 115 millimeter of mercury. And the person's blood pressure at 2 minutes into observation. So P2 equals 115 plus 25 sine 160 pi times 2, which is 115 plus 25 sine 320 pi. Okay, if I have used my calculator, oh, you don't actually have to use calculator, because if you look at pi, so anything with n pi, all right, if n is an integer, sine of n pi is always 0. So therefore is 115 millimeter Hg. Got it? So that is quite a unique trick, quite a unique fact that you need to know.
So, how,
Yep.
why is that?
N pi,
Yeah.
if you look at, if you draw a graph, yx, what is sine 0? Hmm? What is sine 0? Hey? 0. Sine 0 is 0. Up, down, up, down. So here, 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 here. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi.
Induction.
All right? So n pi is always, sine of n pi is always 0. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 6 pi, 7 pi, 8 pi, 9 pi. All right?
So if it's 0.5, what will be the difference?
0, it has to be integer. It says there. Has to be integer. It has to be a whole integer number. All right? So that is something that is worthwhile knowing. For any n pi, sine of n pi is always 0. Got it? Yeah? All right.
Yeah.
So it makes life a little bit easier if you remember that. And example 3. All right. A mass attached to a string is oscillating, moving up and down. This is what I show you. In a simple harmonic motion. You will learn simple harmonic motion hopefully in, well, could be physics. I don't know whether you're doing that in physics now, but I think maths, you'll be doing it. And again, depends on whether you're learning simple harmonic motion from physics point of view or from maths point of view. I got really confused because when I was learning it, I had both teachers teaching different things, physics and maths teacher. Don't worry about it. That was my experience. All right. So a mass attached to a spring is oscillating, that is moving up and down in simple harmonic motion. The graph shows the displacement, xt in centimeter, from equilibrium at the time t seconds into its motion. Determine the function for xt in the form of xt equals to a sine bt. All right? So what you've got here now is you know that there's no phase shift. There's also no equilibrium shift. Right? You are given that equation already. You only need to determine A and B. Got it? So it's pretty straightforward in this sort of question, in a way. Some of them is not. The next example, you'll see that it's going to be slightly more difficult. So you know that we are writing, we know that there is no D or C because we are given xt equals to A sine bt. All right, so we need to know the amplitude. This is equilibrium. What is amplitude? Amplitude A equals to 5. All right, the period. What is one period? 0.4, correct?
Yes.
One cycle is 0.4. So period equals 0.4, and 0.4 equals to 2 pi over b. And therefore, b equals to 2 pi over 0.4, which is 5 pi. So therefore, xt equals to 5 sine 5 pi t. All right? So make use of the information you have. Make use of the information you know. All right, period is 2 pi over b for cos and sine. Now, example 4 is going to be an interesting one. All right? Example 4, it says here, the height of the tide, ht meters above mean sea level on a particular day, has been modeled by the graph shown below. T is the hours after midnight on that day. All right? So here, point 0 is midnight. All right? So this is 6 o'clock, 12 p.m., 6 p.m., and midnight. Right? So, determine the two equations that will define the model. Why two equations? It could be cos, could be sine. Correct?
Yeah.
Now, what you need to think about is where should you start? Are you going to start off with cos or are you going to start off with sine? Does it matter?
No.
Well, in a way, yes, in a way, no. Because the obvious thing is, I will start off with sine, won't I?
Yeah.
Because of that point over there, rather than cos. And then I will do a phase shift to move it to cos. Alright? So if you've got question like this, think about writing the two equations down first. Alright? Writing the two equations down, which is h of t is equals to a sine b t minus c plus d, or h of t equals to a cos b t minus c. Alright? So what I'm doing now here is I'm going to start considering a sine b t minus c plus d first. I'm going to use sine first instead of cos, because it's more obvious. The point there makes it more obvious if I start off with sine instead of cos. Alright? Because sine 0 is 0. Agree? Yeah? So look for the obvious point. So now you know that a equals to 5. Look at that. What is the... Now, beware of the units there, alright? I know in this sort of situation I should have plotted 3 and 5, 1, 3 and 5. But generally, you may not get that. A lot of people may have missed that as a 5. Alright? Read it carefully if you've got any situation. So amplitude is 5 and minus 5. So is A is 5. For sine, there is no phase shift or equilibrium. Correct?
Yeah.
There's no phase shift in this case. And there's no equilibrium shift. So therefore C equals to 0, D equals to 0. Alright? Now period, you're given as 2. Read from there. So 12 equals to 2 pi over b. Therefore b equals to pi over 6. See what I'm doing there? I look at one period. One period is 12. Alright, 12 hours. The 12 hours, and then what I do is substitute the period. P equals to 2 pi over b. Remember that. And therefore you can work out what b is. Pi over 6. So therefore for sine is 5 sine pi t over 6. Now, you need to consider, once you've got the basic one out, think about how do you relate sine to cos. Alright? in order for you to move from sine to cos, or cos to sine, all right? What do? Do you move left or do you move right?
Doesn't matter.
It doesn't matter, but in this case, it actually, if you look at that, what I want is, I want to take away pi over 2 because I'm moving to one direction. All right? I'm just moving into one direction. So I'm cos theta minus pi over 2, which means I am shifting it in the which direction? That direction, correct? Sorry, in that direction, in the positive direction. So I'm going from here to pi over 2. So if I use cos, all right? If I use cos, the point will start off here, and then it's moved across there. Agree? So it's moved across there. All right? By pi over 2. But if you want to move across there, it's not pi over 2. Because you would have, if you want to move in that direction, this will be going down and then up again, and you've got to move from here to here. See the difference? Yeah? Got it? So if you want to move your cos, you've got to be very careful what you do. So if I move from here to here, that's only pi over 2. Theta minus pi over 2. So therefore, substitute that in, pi over 6 minus pi over 2. Therefore, ht equals to 5 cos pi over 2, t minus 3. What I would like all of you to do is to grab your class pad out and plot this. Plot this using your class pad and see whether it works.
Sir.
All right?
Sir.
Yeah?
Shouldn't it
Brilliant.
be plus pi?
Sorry? No. Moving that direction, moving in the plus direction is take away. Remember?
How do you move it this way so
You move it, it's not pi over 2. If you move pi over 2, what happened? You will be up to this point, which is here. Alright? If you move it pi over 2, it will come to here. It's more than pi over 2 that you need to move. It's 3 pi over 2. Yeah. Alright? So, that is pi over 2. So if I move it across here, that's pi over 2 plus, I think, pi over 2. I think, I haven't played around with that. I'm only looking at that direction because I haven't got this bit here on the graph. So I'm just looking at from here to there, that's pi over 2. Alright?
But if you move it that way, that means the maximum of the cos wave is at 0, right?
No, your cos wave is that way. Alright? You still have to move across a bit more. Alright?
Doesn't cos start at
1.
Starts at 1, right?
Yeah, that's right. So 1, move across to there, or move backwards.
But then if you move across this way, then wouldn't the sine curve look like this? Like
You're not moving the sine curve, you're moving the cos curve.
Then the cos curve would be, oh, wait.
Yeah, you're moving the cos curve, yeah? So the cos curve is like this. Alright, the cos curve, let me use a different color. The cos curve is like this. Correct? The cos curve is that way. So you're moving the whole lot across. Either moving the whole lot across or moving the whole lot backwards by a lot.
Yeah, okay.
Got it? Yeah? So it's if you can see the whole wave going from there to there, the cos. Alright? So the green one is the cos. I will always use the maximum point. Happy? Alright? Now this is probably one of the most difficult concepts that you'll come across. I mean, to be honest, when I worked on this problem, it took me a while to work it out as well. Got the first part, pretty straightforward. It's the second part that you've got to really think. How you move it. Okay? I'm going to clear this board and then we'll look at example 5. Alright? Example 5 is a Ferris wheel problem.
Yes.
Why? Why are you so happy about Ferris wheel problem?
Easy.
The Ferris wheel. The height HT meters of a person on a Ferris wheel can be modeled by that equation. So think about the Ferris wheel. You go down and up, down and up. All right? That is probably the most consistent one, the wave you can get. All right? Where t is the number of minutes after the Ferris wheel starts to move. So if you start from the bottom, normally you start from the bottom and go up and then down and so on and so forth. Before I solve the problem, can you read through it please, rather than me reading through it for you? Can you read through the problem and let's think about it. How do we work out the diameter and so on and so forth?
Diameter you got is...
Don't shout out yet, just read through it first and think about it first. I would like all of you to think about it first. First thing I would do is actually sketch. Alright? I would actually sketch. So, if I sketch, if this is the ground, this is the center of the Ferris wheel, something like this. Alright? Not very well done, but you'll see the next one, the next slide. I've done it a lot better. So you can see that what I've done is, that is basically the same, the center of the Ferris wheel, and that's 25 meters. That here, 35. Alright? So the equilibrium point is there. Up 25, down 25. Yeah? So equilibrium point, up 25, down 25. So you got a circle, and you know that the diameter of the circle. So amplitude is 25. Alright? So the wheel will oscillate between, you can see that the maximum point, if it is -1, it's up there, +1 is down here. Alright? Just concentrating on that. Minus will give you that number. Then that will be here. Alright? 28 plus 25 is up there. 28 minus 25 is down there. Alright? 28 plus 25, 28 minus 25. It's not to scale. Alright? So you work out the diameter is 50 meters. Now remember, I'm asking for the diameter, it's not the radius. You work out the radius, but you need to multiply it by 2. Alright? Determine the time taken for the wheel to make one complete rotation. One complete rotation is 1 period. Alright? A period is 2 pi over b, which is pi over 4. 2 pi over 4, therefore it's 8 minutes. Units is important because it's here, number of minutes. 8 minutes. And then determine the height above the ground, the top of the Ferris wheel. Top of the Ferris wheel, 28 plus 25, which is 53. Center of the Ferris wheel, which is the equilibrium point, which is 28. Right? Because it's going down and up, that is the equilibrium. And then bottom of Ferris wheel is 28 minus 25, which is 3 meters. That's the center. 28. Alright? You must have certain clearance from the ground. It cannot touch the ground. So therefore, you can actually sketch that. Now, use your class pad to plot this, please. Can you use your class pad to plot? Yeah? Try using your class pad to plot. If you're asked to plot something like that, always use your class pad and then transfer it. Makes life a little bit easier. Always think about that. Use your class pad. Generally, if the question asks you to sketch, you need to put in the maximum and the minimum point. And if there's y-intercept, you put in the y-intercept, or the x-intercept, you put in the x-intercept. The maximum and minimum point and the equilibrium. So in fact, I did not even use my class pad because of that I know that period is 8 minutes. And I know that I will have to start always from 3. So if I go to the Ferris wheel, I cannot start anywhere else. I've got to start right at the bottom, correct? So for me, the Ferris wheel will take me all the way up to 53 meters and down and up and down again. 16 minutes, 2 cycle, 2 rotation, and I'll be back. And then you can work out HT, H2, and H5, and then you can work backwards to find T. All right? Of course, you can use analysis if you want. Fine. Make sure that when you plot using your class pad, it's in radians.
How do you do this in your class?
Sorry?
Do you put on graph and table?
Yeah. All right, let's try it. Okay? Let's try it. All right, let's try it with ClassPad. Good question. All right, oops. What's wrong with my ClassPad? Yeah. Okay. So, go to graph and table. Ooh. Let's clear everything. Don't worry, that's nothing to do with your test. So, it's 28 minus 25. See, I put this as radian. It's important. Minus 25. Yeah. Cos pi. I'll have to use x. Oh, actually, before that, I prefer to do that. Pi x divided by 4. All right. Oh, you can see that very clearly. So let's zoom in. Oh, actually, auto. You can see that, but I still want to go a bit further. I want to see 2 cycles. Right. So let's go here. X equals to, let's say, that's fine. And scale is 1. Y mean is, oh, hold on. X, I want to go from 0 to, let's say, 18. All right, X mean is, max is, yep, 60. Click OK. You can see that. You've got the graph. So you know where the maximum point is by doing analysis. G-solve, max. 1 point, 2nd point. All right, you can find the 3rd point, doesn't matter. Analysis, G-solve, mean. Start from there, back, back. All right. It can't see that big, so it can't go back any further. But you do know you can get the numbers. All right. And then think about analysis. You want G-solve, solve for X-cal and Y-cal. So if I want X as, let's say, Y value is 25, tap OK. It will give you that value. Pretty much useful, really useful knowing how to use your class pad. If you don't know how to use your class pad, it's going to be, you'll be in trouble in this sort of question. Always use your class pad. All right? So what I'm going to do is I'm going to stop here now. You should have enough exercises for you to do. And please do the exercises